everyone. All right, we're going to talk about parent functions and transformations. So we're going to graph the functions and talk about domain, range, and we'll do intervals of increasing and decreasing when we need to. So I just want to mainly talk about the actual parent functions themselves. So the first one that we have is called a constant. It's called a constant function. It's when your function is equal to some number. Okay, so that would basically give you a horizontal line. Okay, it's constant. It's not moving, it's not doing anything, it's just there. Okay, it's equal to some number. The second one that we're going to talk about is linear. Okay, linear you're pretty familiar with. It's when your function is equal to x. Okay, that's that parent function. So when we're doing our parent functions, you're going to see the very basic of parent functions, okay, of the function. There's not going to be any moving. There's not going to be any flipping or turning or anything like that. A parent function is where the function starts and originates, but you can do more with it. So your parent function here for linear is y equals x or f of x equals x. Remember, y and f of x are the same thing. And it's just going through the origin and it has a slope of 1. Okay, so the next one we're going to talk about is absolute value. Okay, so absolute value. So it's when your function is equal to the absolute value of x. So this is your parent function. Again, very basic, nothing's being done to it. So remember, your absolute value is going to give you a v. You're going to have all positive values because of what absolute value represents. So you're going to have this v, it hits at 0, and it'll look like that. Okay, so that's 3 of them so far. So then I want to move into quadratic. Okay, quadratic. So that's when your function is equal to x squared. Okay, again, parent function, very basic. So your parent function here, that you've seen a lot before, has these standard points and it is symmetric. So when you plug in 1, you get 1. When you plug in 2, you get 4. And that's your parent function. Okay, 0, you get 0. So the next one, we're going to talk about a cubic. Okay, so again, that's when your function is equal to your variable cubed, and nothing fancy or done with it. The 3 points you need to have are right there, 1, 1, 0, and -1, 1, or -1, -1. When you plug those in, you will get those out of it. So those are like the 3 basic points that you have for those. Okay. And then the last one on this line that we're going to take a look at is our square root function. Square root, and that's when our parent function is just equal to the square root of our input, so square root of x. So if we plug in 0, we get 0. If we plug in 1, we get 1. You really just want to do perfect squares. So if I plug in 4, I should get 2, and it is going to go increasing to the right, okay, as x is getting positive, y is getting positive. Okay, so we have these transformations so far. Okay, so make sure you have those. And then we're going to go to the next page. And we have a few more we got to talk about. So next one, we have exponential. We have an exponential function. So that is where your y equals, your f of x is equal to some base. So some base a, and your x is in the exponent. Okay. So what that looks like is you always have this 1.01. Okay, if x is 0, you get 1 no matter what. So we call that an anchor point. Okay, it kind of anchors your graph. So when we transform our graph, you can use that to help move things around. It makes it a little easier. So then our exponential function is going to approach 0 but not equal 0. It'll go through that anchor point and go up. Okay, so our exponential function looks like that. So now our next one we're going to talk about is a log function. So logarithmic function. and that's when your y, or f of x, is equal to the log of some base a of x, log base a of x. And it's very similar to your exponential function, and because they're inverses, and we'll talk about that this year. The anchor point here is at 0, 1. Okay, so this one does have an anchor point as well, and it is at 0, 1. It's going to approach your y-axis but never hit it, and it's going to go over to the right. Okay, so just a couple more. So another parent function that we have, we call it a reciprocal function, reciprocal, okay, reciprocal function. So that's when your y, or f of x, is equal to 1 over x, okay? And this is one where you have the split. You're going to have these two that approach the axes and they never cross, so they're asymptotes. So it'll look something like that. And as you add things to it, it will change. So there is one more I want to talk about. We don't use it very often, but I do think that you should see it. All right, so the next one we're going to do, it's called your greatest integer function. Okay, your greatest integer function. So it's when your f of x is equal to these brackets of x. And what happens is it's the greatest integer, so you end up getting a piecewise function. Okay, so you're going to put a solid dot on 0 and then an open dot on 1. And you're going to keep doing this pattern. That's a open dot. If you can't tell, you're going to have open dots and then closed dots on top. We used to call this a step function. Okay, so you can see it makes little stairs, and as you add the transformations in here, it'll move around. That's not right. It'll move around and you can graph it. So I wanted you to see a piecewise function, and this does this forever and ever and ever because it is a function. It is going to do it all the way to the right and all the way to the left. So it doesn't just stop. So I definitely wanted you to see that one because this is a piecewise. Okay, it is a piecewise function. It's also called a step function, okay, because it looks like little stairs. Okay, so I just wanted to make sure you saw those. If you look, I'm gonna take a look at this. So exponential and logarithmic are inverses of each other. So you can kind of see that if you were to reflect them over that y equals x invisible line, that they would be inverses of each other. And then quadratic and square root are also inverses of each other. It's just square root, sorry, square root, we don't draw the other half because we can't have negatives in our square root function. Okay, that gives us complex answers, and we're not there yet. Okay, so those are our parent functions. Again, those are the functions that when you start moving things around, that's the starting point. That's the basics. So when I ask you to graph the parent function first, that's what you're going to do. You're going to draw this function, whatever it is, and then you're going to transform it. So the general form for transformations is f of x equals a times bx minus h plus k. Okay, so we're going to talk about the order of which you do things. Okay, we're going to talk about that order. Sometimes you'll see this as f of x is equal to c times bx minus a plus d, just because it's alphabetical order of how you do things. But this is the main way right here, because you need to know what h and k represent. So for this first one, this is going to be for h, okay? This is a shift left, or right, all right? So if you're shifting left or right, you can see that it's a minus in the form. So you know to shift left when you have a plus going on inside. You shift right when it's still minus. Because what's happening is if you have a shift left, let's say it's x plus 2, this is really x minus a negative 2 because the general form starts with a negative. So that's why you're shifting left on the x-axis when you have something like that. So it's the opposite of what you want to do. If it's minus, you're going to go right. If it's positive, you're going to go left. Okay, if it's plus. So then the next thing we're going to take a look at is this this b out front. There's a couple things that you need to take a look at. So this is really 2 steps in one. So plus or minus your b. So the b itself is a horizontal either compression or stretch. Okay, so it's stretching along your x-axis. So a compression or a stretch, it's going to either be super flat or super steep. We're not going to do too much with evaluating b, but what I want you to take a look at is when you have a plus or a minus b. Okay, a minus, if you have a minus b, how do I want to write that? So a minus b means that you have a reflection over y. So I always like to say inside y. Okay, if you have a negative on the inside, then you're reflecting over your y-axis. Okay, that would seem to be very helpful last year for some of my kiddos. So inside y. If it's on the inside, if you have a negative b, a negative in front of that x, whatever it is, -1, -2, whatever, you're going to reflect over your y-axis, inside y. So then the next one is a plus or minus a. So the a part is a vertical compression or stretch. Okay. Again, we're not going to do too much with actually like evaluating those. You just have to be able to graph them. So this is also similar to the B. If we have a negative A, what that means is we have a reflection over our x-axis. And so if you can remember that inside y is reflection over y, then any other negative out there is going to be an x reflection. It's going to reflect over your x-axis. So if you can remember this inside y piece for the negative in front of x, the outside is x. Okay, out x. Inside y, out x. Okay. So at this step, you need to double check your reflections. Okay, double check your reflections and make sure that you've done inside y or outside x. And then the last one is this k. That's going to be a shift up or down. Okay, so a negative k is a shift down. A positive k is a shift up, just like the formula has. It's a plus k in your formula, so if you have a negative k, that means you have a negative number. If you have a plus k, that means you have a positive number. H is the only one that's kind of weird because of the way it's set up. Okay, so these are your steps. You need to do them in this order. So the first one, you've got H. Second one, you're doing your compression, stretch, and reflection. Third one, again, compression, stretch, reflection. Double checking everything you've done so far, and then doing your K, because the shift up and down is really easy. So that can be your last one. So I want to take a look at the graphs at the bottom of this page. Okay, so looking at number one, it's a cubic. So I want to first, I need to draw the graph for this cubic, but the first thing I'm going to do is draw the parent function. So I want you to go ahead and do that now. Okay, so this is my parent function. This is y, or f of x equals x cubed. Okay, this should be in your notes. Always draw the parent function first. That way you know where to start from, so you know where to go. So according to the steps that we just wrote, the first thing we're going to do is this h. Okay, we don't have a b. We do have an a right here, so we're going to do that second. So the first thing I'm going to do, I'm going to look at this h. It's a -2, which means I have a shift left 2. Okay, I'm just gonna put L2. We're gonna, not left, I'm so sorry. Right 2. Okay, we're gonna go right 2. Because the negative is there, we're gonna go right 2. So these 3 points that you need, -1, 0, and 1, 1, we're gonna shift them over 2 spots. And then because I'm not done, I always like to put my graphs in dotted lines to show that I'm not finished yet. Okay, so it should be similar to what you just wrote, except now it's shifted. Okay, so that one's done. So now the second one is a reflection, but it's on the outside of the parentheses, so that is a reflect over your x-axis. So basically you're flipping this function up and down. Okay, so if it's on the x-axis, it's not moving. This one negative one will now move up into the first quadrant, and this 3 positive one will move down. And because that's the last transformation I have, I'm going to make a solid line with my graph. Okay, so then that's done now. And that's my final answer. So somehow you need to indicate that that's your final answer, whether doing it like I just did it with the 2 solids and make sure I know which one's the final. You could just write final next to it and make sure that it's very clear which one you're talking about. However you need to do it, you need to take care of that. So I want to take a look at number 2. Okay, number 2, we have a square root function. So we need to start with our parent function. So go ahead and graph the parent function now. All right, so my parent function is in the black like it always is. So now we have g of x is equal to negative square root 4 plus x plus 1. So this doesn't look exactly like what we started with in our original form. So if it helps, you can rewrite it so that x is first and 4 is second. So for this one, I have a plus 4. I don't have anything in front of the x. I have a negative on the outside, and I have a plus 1 on the outside. So I'm just going through those blocks that we just wrote in and seeing what I have and then numbering them so I know to do them in the correct order. So the first thing we're going to do is take a look at our shifting left and right. Because it's a positive number, we're going to shift left 4 spaces. So all these points, these 3 points that I needed, I'm going to go left 4. So 1, 2, 3, 4. And then 1, 2, 3, 4. And remember, I like to do the dotted line so I know this isn't my final. It's just one of my steps. Okay, so that's done. The second thing we're going to do, we have a negative on the outside. So it's not a vertical compression or stretch because there's no number, but you do have a reflection. And based off what we just did in number 1, it's a reflection over our x-axis. Remember, if it's not on the inside, it's an x-axis. So inside y, outside x. Okay, so we're going to reflect it over the x-axis right here. So this point that's on it stays. This one at -3, +1 is going to shift down, going to flip down over, and it should really be a mirror image of what you had above. Okay, so there's that. Okay, that's my second one. And then my last and final one, I have a +1 at the end, so I'm going to shift up 1 unit, so all of my points will move 1. So up 1, up 1, up 1, and then this is my final. So I am going to connect my dots with a solid line and make sure your arrows are on there. If you're using different colors, it helps. So like that you can tell is the final. Or if you write right next to it, make sure it's clear which one is final. Okay. So at this point, I want you to go ahead and do number 3 on your own. So go ahead and do that now. All right, so this is what I got for number 3. If it helps, rewrite it so that the x is first and the negative does go with the x. So it's going to be absolute value of negative x plus 1. Whole thing is plus 3. So parent function is absolute value. Moved it left 1 because it's a plus 1. Reflected it over my y. Okay, reflected it over y this time because it's on the inside. And then for your final one, you needed to move it up 3. So I'm just writing what I did because I did not do that yet. So we went up 3. And sometimes it helps to list it. You should be able to list what it is by looking at it. So listing it each time with your graph is really important. So at this point, I want you to go ahead and do 4 and 5 on your own. Okay, so draw your parent function and then do the transformations. Okay, so go ahead and do that now. Okay, so for number 4, you had a quadratic, so you should have graphed your parent function, moved left 2, reflected over y because it's inside y, and then moved everything down 7, so do your best with that. And then for 5, parent function of square root, reflect over your y, and then reflect over your x. Okay, so if you have any questions, please let me know. Other than that, have a great day.